All right, this is a fascinating story. I'm joined by Dr. Paul Bishop, who is the C.D. Howe Research Chair in the Mechanical Engineering Department here at Dalhousie University. And there is an incredible collaboration happening between Dalhousie and the Canadian Navy. First of all, thank you so much for letting us in here.
My pleasure.
What exactly are you doing with the Canadian Navy?
What I and my team, in fact, are doing with the Canadian Navy is trying to give them the information they need to leverage 3D printing to make replacement parts for vessels like submarines.
Yeah, and some of these submarines that our Canadian Navy is using are made in the 80s.
Correct.
And the companies that would manufacture replacement parts don't even exist anymore.
Correct. Which means that to get a replacement part, it costs many dollars and can take months just to get a singular part. Whereas with 3D printing, once you have the required approach nailed down, which is what we do at Dalhousie, you can print a part in a matter of hours or days.
Fascinating. Now you have this incredible piece of equipment here which is unique to Dalhousie University. What is it?
Yeah, this is our gas atomizer, and this is where we convert solid metallic materials into a powder form that we need as the feedstock for the 3D printing process.
Okay, so the 3D printer prints with materials, like it uses this powder?
Powder just like this that we printed here at the lab.
Can I hold that?
Absolutely.
This is heavy.
Yeah, it's a nickel aluminum bronze powder, copper-based alloy.
It's that?
This is what it originally was, which is a piece of a decommissioned component from a naval vessel that we are then basically recycling into powder to recycle and turn into new parts for vessels like submarines.
This is fascinating. All right, let's look at the next step of the process.
Sure. Great. So we're here at the Advanced Manufacturing Hub here in Mechanical Engineering, and this is where we do all the metal 3D printing research for the Canadian Navy and the other partners involved.
Okay, so there are many different types of printers in here. And look, the powder, very similar type of powder, different alloy, but similar. This is what the powder can create.
Yeah, the level of detail and resolution is pretty amazing. We have 3 different technologies here that we're using, but in the interest of time, we'll just focus on one.
Okay, well, all right, this is super heavy. Can I put this down?
Yeah, please do.
Let's go back over to the machine. Okay,
yeah.
Fantastic. So, Dr. Bishop, what's happening here?
What we're doing here is a technology called directed energy deposition. And the Navy's interest in this technology is that we can use it to repair worn or damaged components so they can be put back into service in a fraction of the time and at a fraction of the cost.
Oh my gosh, so this could literally save millions of dollars.
Yes, absolutely. This is a game changer for the Navy in a lot of different circumstances. And we can really get that vessel back in service in a very short period of time.
So what's happening inside the machine is you would be making parts like this?
That's correct. This is just a demonstration part, an impeller that we designed and developed, and the entire ring and all of the fins are printed from metal powder directly that we processed in the gas atomizer.
Fantastic, and this is an interesting concept.
Yeah, this is a different technology. This is really sort of epitomizes where the repair concept comes into play, where you can take a pre-existing material, this pipe, if you will, and with this technology you can overlay different materials that have different properties, better corrosion resistance, or rebuild a worn surface so that that part can be put back into service.
That's fantastic. And what are the greater benefits to the technology that you're doing for Canadians and the Canadian Navy?
The main benefits really are to keep everything within Canada, to keep everything secure, and hopefully to grow an ecosystem within the defense sector where there'll be many companies doing this sort of work for the Canadian Navy.
And I know you're headed to a defense conference. It's very exciting that Dalhousie University is on the forefront of this type of technology.
Yeah, it's been a great development for the university, and with our proximity to the Canadian Armed Forces and the naval base, of course, it's been a real win-win advantage situation for everybody.
Yeah, and it could technically save millions of dollars if you can repair with this machine. Think about all the money that it could save.
Correct, millions of dollars, and potentially save years of downtime for a vessel if you can repair it rather than replace it.
Well, Dr. Bishop, thank you so much for the tour of your lab today.
My pleasure.